Hello, this is Mr. Zanaletto again. Here we are with lesson 2.5, solving rational inequalities. These are the steps I would suggest you taking. Write each inequality so that everything is on the left side and the zeros on the right. Determine the values of x where there is undefined. When I do this, number one, on this first example, you'll see, and maybe even number two, we're going to try to flatten it out and then go from there. And I hope that was something you learned in Algebra 2, but if not, you'll see what I'm talking about in just a minute. Then we're going to determine the values of x where we're undefined, which give us critical points. And once we have those critical points, that breaks up the number line into different areas that we can go ahead and test and know whether the whole area is true or the whole area is false. So let's go ahead and get started. On this problem, let's see some. Okay, so on this problem, we're going to go ahead and, again, get everything to one side. I have 4x plus 5 over x plus 2. Subtracting 3 is greater than or equal to 0. Now I'm going to multiply everything by x plus 2. But remember, when I multiply this side by x plus 2, I have to distribute it to here and here. When I distribute it to the first part, the x plus 2's cancel, and I get 4x plus 5, which is a nice thing. When I multiply it times negative 3, I have to distribute negative 3 times x is a negative 3x. Negative 3 times negative positive 2 is a negative 6. And that's all greater than or equal to 0. Combine like terms, and we get x minus 1 is greater than or equal to 0. Now remember, when we started, we had an x plus 2 on the bottom. And just like back in section 2.3, we can't let that happen, because if that equals 0, it's undefined. So one critical point that we would have, that we would be concerned with, would be x equals negative 2. Another critical point would be when this equation's true. Let's go ahead and add 1 to both sides, and we get x is greater than or equal to 1. X equaling 1 would be a critical point. So really, last time I did this, I think I had a number line, but I'm going to go ahead and just sketch this out. This is more just work area. I have a 0 here, and my I have 1, 2, negative 1, negative 2, negative 3, negative 4. And my critical points, they're equal, so they're going to be included, is at negative 2 and at positive 1. Now, I need to go ahead and test. My test points I'm going to check are 0, this point right here at 0. I'm going to check 2, and I'm going to check negative 3. So I'm going to plug those into the original equation and see if they hold true. When x equals negative 3, that to the left, negative 3 gives me negative 12 plus 5. Negative 12 plus 5 is negative 7. Negative 3 plus 2 is a negative 1. And I'm asking myself, is that equal to or greater than 3? That 7 is greater than or equal to 3. That is true. Well, if that's true, I'm going to go ahead and shade towards that point. And it's going to be here. That's going to be true. Now, let's plug in 0. When x equals 0, I plug in 0, I get 5 over 2. As I plug in zeros for the two x's, that makes 5 over 2. That's really 2.5. Oops, this is getting a little sloppy here. Let me try to clean that up. I get 2.5 is greater than or equal to 3. That is false. So far I had a true for 3, negative 3, and I had a false for 0. Now I want to check x equals 2. X equals 2 is 8 plus 5. 8 plus 5 is 13. 2 plus 2 is 4, greater than or equal to 3. 13/4 is really, that really is 3 1/4. 3 1/4, 3.25, greater than or equal to 3. That's true. 3 1/4 is greater than $3, so that's true. That was when I put in T, so that means that I do shade towards that. So now, when I want to state my answer here, I typically I can state it as an inequality. X is less than or equal to -2. And, what should I say? Wait, let me think about this. X is greater than or equal to -2, or X can be less than, greater than or equal to 1. Which, in interval notation, is simply -infinity to -2, including it, bracket, the union of that set, and the union of 1 to positive infinity. So that's my answer for that problem. I worked through, I found my 2 critical points by looking at when my denominator would be 0 and when my equation would hold true, and then I plugged that in. So we get those 2 answers. The next problem we're going to try. We're going to try 2 problems. This is the second of 2. On this problem, it gets a little more dicey as far as getting rid of all of this, but I like to go ahead and do it the way we said. We're going to go ahead and move everything over to the left. 7 over x plus 3 minus 6 over x plus 2 is greater than or equal to 0. And I'm going to multiply all of it by x plus 3 and x plus 2. I'm going to multiply that. I'm going to multiply this, but that's going to end up becoming 0. So I'm not going to even write it over there. I'm going to write 0. When I distribute both of these times 7 over x plus 3, the x plus 3's cancel, and I get 7 times x plus 2. Minus, I distribute it there, I get minus 6 times the x plus 2's cancel, and now I get x plus 3. Distribute, you get 7x plus 14 minus 6x minus 18, which really gives me x minus 4. X minus 4 is less than or equal to 0, so x is less than or equal to 4. There's a nice answer to that. Now, back to what we were talking about, critical points. My critical points that I get when we've had denominators being 0, x equaling -3, x equaling -2, and then we get our solution, x equals 4. So now we have 3 critical points, which makes 1, 2, 3, 4 different areas. And what I mean by that is if I draw my number line, I have 0 here. I'm interested in 4's over here, -2's over here, and -3's over here. And I'm looking at that. So where would be some good critical points? Test points. Well, first of all, these were critical points, but 4 is a true point. So these would be, we're not going to include those because we can't. They're not part of our solution set because they make the initial inequality false or undefined. But the other one, 4, is true, so I'm going to go ahead and make that a solid point. So there I am with my solid and dotted. Now I need to go ahead and come up with some values to plug in. I'm going to plug in x equals -4. I'm looking through my notes, but I believe this is, it's got to be x equals -4, x equals -2.5 or -5/2, which will be in between there, x equals 0, and x equals 5. I have 4 values to plug in now. So when I plug those in, when I plug in -4, I get 7 over negative 1, which is negative 7, less than or equal to 6 over negative 2. 6 divided by negative 2 would be negative 3. Is negative 7 less than or equal to negative 3? That's true. So far, I do want to include negative 4. It's going to be out here. Now, when I plug in that value between negative 3 and negative 2, that negative 5 halves, that's negative 2.5. That makes my value there 7 over negative 2.5, that's 1/2. That's going to be 14. 14 is less than or equal to negative 1/2. 6 divided by negative 1/2 would be a negative 12. Negative 12, which is false. Negative 12 is not greater than, or 14 is not less than or equal to negative 12. So that's false. This is false. And I'm going to say in between here is false. This was false. Over here was true. Now plug in 0. When I plug in 0, I get 7/3 compared to 3. Well, 7/3 is really 2 1/3. Wait a second. I plug in 0, I get 7/3. 7/3, it goes into it twice, 2.3, repeating. And when I plugged in 0 there, 6 divided by 2 is less than, that's true, that's right, is less than 3. That's true. If that's true, 0 is true. Now we need to shade in between negative 2 and 4. Now when I plug in 5, I get 7/8 is less than or equal to 6/7. I'm going to multiply the top and the bottom by 7 on the first equation, 49/56, compared to multiply by 8, you get 48/56. 49/56 is not less than 48/56, so this is false over here. So I'm talking about those two intervals. With those two intervals, I'm going to go ahead and give myself a little extra room, and I'm going to go ahead and write down, what does this really represent? This represents x less than negative 3, or x is greater than negative 2, but less than or equal to 4. That's how I'd write it within inequality. As far as interval notation, that would be negative infinity to negative 3, not including, and the union of that, and then negative 2 not including, but to 4, which we do include when we put a bracket. So those are the two ways I would write that, and we're done. Those are the two examples I had there. I hope that helps. We found our critical points. Once we found our critical points, we went ahead and decided on 4 points for the 4 intervals that we were interested in. And we found out the first one was true, the second one was false, the third one was true, and the fourth one was false. So we had this infinite thing going off to the left, the segment in between with the right endpoint being part of it, the left endpoint not being, and then the right interval not being true at all. So hopefully that helps. Have a good day. Again, I would check, and I believe there's a Delta Math that is excellent for this. Have a good day.